In this video, I'm going to share about solid. First, I'm going to share about the properties of solid. Second, I'm going to share about the processes involved solid, such as melting, freezing, sublimations, and depositions. And then we are going to look at the differences between crystalline solid and also amorphous solid. And the very last part, we are going to look at 4 different types of crystalline solids. Hey, I'm Teacher Tang. If you like my video, do remember to click on the subscribe button below so that you won't miss any notification as I update my channel.
A solid has a fixed shape, definite volume, and is almost incompressible. Why? It is because solid particles are closely packed and in highly ordered arrangement. The intermolecular forces between the solid particles are very strong to hold them at the fixed positions. Hence, solid has a fixed shape and definite volume. And there are only little empty spaces between the solid particles. Hence, the solid is almost incompressible. What is freezing? Freezing is a process where a substance changes its phase from liquid to solid. In terms of kinetic concepts, during freezing, the temperature decreases, causes the liquid particles to lose their kinetic energy and moves slower. Liquid particles with lower kinetic energy are attracted more strongly by the intermolecular forces, and the strong intermolecular forces then hold the particles in more ordered manner and into fixed positions to become solid. What is melting? Melting is a process where a substance changes its phase from solid to liquid. In terms of kinetic concepts, during melting, temperature increases. This causes the solid particles to gain kinetic energy and vibrate faster. Solid particles then gain enough kinetic energy to overcome the intermolecular forces between them and break freely from the fixed positions to become liquid. What is depositions? Depositions is a process where a substance changes its phase from gas directly to solid without going through the liquid phase. In terms of kinetic concepts, when temperature decreases during sublimations, the gas particles lose their kinetic energy and move slower. When the gas particle moves slower, they cannot overcome the intermolecular forces between them when colliding with the solid and trapped as part of the solid. What is sublimation? Sublimation is a process where a substance changes its phase from solid directly to gas without going through liquid phase. In terms of kinetic concepts, during sublimations, when temperature increases, solid particles gain kinetic energy and move faster. When the solid particles with greater kinetic energy and vibrate faster, they could overcome the intermolecular forces between them and break freely from the fixed positions to become gas. In terms of arrangements of particles, crystalline solid particles are in ordered and well-defined arrangements to give flat surfaces or faces with definite angles. For amorphous solid, the particles do not have ordered arrangement. Therefore, amorphous solid have lack of well-defined faces and shape. For crystalline solids, they are being formed when the saturated liquids are being cooled down slowly. The amorphous solids are formed when the saturated liquid is being cooled down rapidly. For crystalline solid, because the saturated liquid is being cooled down slowly, this causes the crystalline solid to have more ordered stacking of particles in the structure, and the solid also have long-range repetitive patterns. For amorphous solid, because the liquid is being cooled down rapidly, that's why the particles in the amorphous solid do not stack well together. And in the solid, they do not have long-range repetitive structure, but consist of long chain-like molecules that are intertwined together due to the rapid cooling during the formations of the solid. In terms of melting point, crystalline solids melt at a specific temperature and shatter regularly. For amorphous solids, they do not melt at specific temperatures and shatter irregularly. Examples of crystalline solids include ice, graphite, silicon, diamond, and sugar. For amorphous solids include glass, plastic materials, charcoal, and rubber. And the diagram here shows the long-range repetitive patterns in the crystalline solid, and the diagram here shows there is no long range of repetitive structure in the amorphous solid. There are 4 types of crystalline solids: metallic solid, ionic solid, molecular solid, giant covalent solid. All of these crystalline solids have different arrangements of particles and attractive forces between them. And the attractive forces and arrangement of particles will determine their physical properties such as the melting point and hardness. For metallic solid, the metallic solid composed of atoms of same matter linked together by metallic bond, and they are closely packed in the structure. What is metallic bond? The metallic bond is the interparticle forces in the metallic solid, and basically metallic bond consists of positively charged metal ion attracted to the negatively charged sea of delocalized electrons, and this extended throughout the crystals. And still remember, metallic bonds can use electron C model to model it as in the diagram. For physical properties of metallic solid, the softness can range from very hard to very soft, and the melting point can also range from high to low. For metallic solid, they can conduct electricity in both solid and liquid states, and all metallic solids have shiny surfaces. Examples of metallic solid include copper, silver, iron, sodium, mercury, and others. For ionic solids, the structure consists of positively charged ion, cation and anion held together by strong electrostatic forces called as ionic bond. So the interparticle forces is the ionic bond, the electrostatic forces that held the positively charged cation and the negatively charged anion together. The physical properties of ionic solid include relatively hard but brittle, and ionic solids, they are non-conductor in solid state, but they are conductor in the molten and aqueous state. And generally, ionic solids, they have relatively high melting points. Examples of ionic solids include sodium chloride, sodium nitrate, calcium chloride, and others. For molecular solid, the structure composed of molecules or atoms held together by intermolecular forces such as hydrogen bond and van der Waals forces, or just the van der Waals forces. Hence, the type of interparticle forces will be van der Waals forces or van der Waals forces and hydrogen bonds. For molecular solid, the physical properties include soft, low melting points, and non-conductors of electricity in any states. Examples of molecular solid include ice, dry ice, iodine, as shown in the diagram. For giant covalent solid, the structure composed of atoms linked together by covalent bond to form very large molecules. So the interparticle forces for giant covalent solid will be covalent bond, and there are infinite numbers of strong covalent bonds in the giant covalent solid. The physical properties for giant covalent solid include very hard, have very high melting points, and they are non-conductors of electricity. Examples of giant covalent solid include diamond and also silicon carbide and others.